Ravi sir, good morning.
Good morning, madam. கேக்குதா?
கேக்குது சார்.
audible? கேக்குதா?
கேக்குது சார். It's audible sir.
Okay. மேடம்
Agastha madam,
சார்
it's time.
ஓகே சார்
Dr. Raja.
இன்னைக்கு சாங் போடுவாங்களா சரவணன் சார்?
சார்
Amma, we shall start.
சொல்லு கிருஷ்ணா. சொல்லு. சரி அந்த கிருஷ்ணா நான் ஃபாலோ பண்ணிக்கிறேன்.
வாழ்க்கையெல்லாம் கல்விதானே வரமாகும். காமராஜ் கல்லூரியில் பொன் விழா கோலம். பொன் விழா ஓஹோ பொன் விழா பொன் விழா பொன் விழா ஆண்டிலே ஆனந்தம் கொண்டாடும் நேரமே இது காமராஜ் கல்லூரியில் பெருவிழா சந்தோஷ பெருவிழா. இது காமராஜ் கல்லூரியில் பெருவிழா சந்தோஷ பெருவிழா. இடமே மதித்திட கல்வியில் உயர்ந்து நின்றோ. கல்லூரியே
சோலைவனமானதே
பூக்கள் சூழ
திங்கள் வந்து வீசுதே.
கல்லூரியே
சோலைவனமானதே
பூக்கள் சூழ
திங்கள் வந்து வீசுதே. வாழ்க நம் கல்லூரியே ஆட மாணவனே.
வாழ்க நம் கல்லூரியே ஆடு மாணவியே. வாழ்க்கையெல்லாம் கல்விதானே வரமாகும். காமராஜ் கல்லூரியில் பொன் விழா கோலம். பொன் விழா ஓஹோ பொன் விழா. ஏழைகள் வாழ
ஏடியாய் இருந்தார்
எங்கள் வாழ்வில்
கல்வியை கொடுத்தார்
ஏழைகள் வாழ
ஏடியாய் இருந்தார்
எங்கள் வாழ்வில்
கல்வியை கொடுத்தார்
யாக வாழ்வுற்றவர் நம் வாழ்வில் ஏற்றம் தந்தவர்
வாழ்வையேற்றவர் வாழ்வின் ஏற்றம் தந்தவர்
வாழ்க்கையெல்லாம் கல்விதானே வரமாகும்
யா யா யா
காமராஜ் கல்லூரியில் பொன் விழா கோலம்
யா யா யா
பொன் விழா
பொன் விழா
ஓஹோ பொன் விழா
பொன் விழா
பொன்விழா பொன்விழா ஆனந்தம் கொண்டாடும் நேரம் இது காமராஜ் கல்லூரியில்
பெருவிழா
சந்தோஷ பெருவிழா இது காமராஜ் கல்லூரியில்
பெருவிழா
சந்தோஷ பெருவிழா
Thank you, sir.
Okay, start.
Thank you, sir, for the wonderful song about our college. A very good morning to all. We are very happy to meet you all again in the second day of international webinar on intelligent data analytics. May the Lord Almighty bless today's session also. Let's start the today's session with a warm welcome of Professor T. Ravi, Associate Professor of Kamaraj College, Thoothukudi. I invite Professor T. Ravi to welcome the gathering. Welcome, sir.
Can you hear me, madam? Can
Yes,
you
sir.
hear me?
Yeah.
Good morning, everyone. Respected our Secretary, A. Rajendran, beloved our Principal, Dr. D. Nagarajan, Convener and Head of the Department, Dr. V. Joseph Raj, Professors, Scholars and Students. It's a great pleasure to welcome you all to the international webinar series on intelligent data analytics organized by Research Department of Computer Science, Kamaraj College. Yesterday, we had very nice webinar on big data research and analytics presented by Professor Dr. D. Peter Augustine. Now, I am pleased to welcome Dr. A.H. Raja, Associate Consultant, will give you more details about data science in the real world. I hope this program will will help you more productive and smart. Have a wonderful day. Thank you, sir. Thank you, madam.
Thank you, sir, for your cheerful welcome. We are drowning in flood of data, and so now the data science is ruling over the world. Well, now let us hear the most required topic of current scenario, the data science for real world, from Dr. A.S. Raja, Associate Consultant in Enversnet, Kerala. Before that, I would like to introduce today's resource speaker. Dr. A.S. Raja has more than 15 years of experience in teaching as well as in building systems based on machine learning and engineering. He has completed his PhD in the area of neural networks in Satyabama University, Chennai. He proved his research excellence by his more publications in reputed journals and international conferences. Dr. A.S. Raja received Young IT Professor Award at the national level from Computer Society of India in 2011 for the project The Darknet and the multiple national level awards for technical work. Moreover, he is being the adjunct faculty and board of study member at Karunya University. Currently, he is leading a team of engineers and analysts and has built a lot of machine learning algorithms applications using R, Python, Tableau, and SQL, etc. Also, he has an experience on conducting training and bootcamp for new hires on machine learning and data science. I think we are very blessed to have such a distinguished resource speaker with us today. Now I invite Dr. A.S. Raja to share his practical knowledge on data science with us. Welcome, sir.
So thank you, ma'am, for the nice introduction. Good morning, one and all. So one thing I add up to the introduction is I am your HOD, Dr. Joseph Raj, PhD student. He was my supervisor, and I was a pretty ordinary guy, and I started my career as a lecturer in Cape Engineering College. And my association with Dr. V. Joseph Raj, especially in terms of the PhD, and most importantly, he showed, he shaped my career by introducing, neural networks into my life. So my PhD was, in neural networks, and I believe that work has totally transformed, and definitely the work, as well as Joseph Raj sir, is I'll be always grateful, and that association, that work with under him have really transformed my career from teaching to an industry. So with that words, again, Kamaraj College is not new to me. I have come there for 2-3 occasions to meet my guide, to discuss about things. So really, amazing person you have got as a HOD, a very simple and a humble person, and most importantly, a very straightforward and work-focused person. So really, I feel tremendous pleasure in expressing my gratitude to my guide, to my well-wisher, to my mentor on this occasion, especially to his department, faculty, and the students. So let's go into the topic. See, it's pretty important topic in today's context, and most importantly, yesterday you could have heard a lot about big data and all those stuff. So obviously, here comes the topic which will ignite you or trigger you to to say what are we going to do with those big data. So it's just an 1 hour or less. So I'm trying to answer only 2 questions. What is it? Because I understand even some newbies are here, especially students where this thing may be new to them. So what is it? And secondly, a lot of people may be having a confusion in their mind, is this something related to me? Is this something relevant to me? Yes. So these will be the 2 primary questions I'll be answering up using my practical exposure and the expertise which I have built during my PhD work, as well as my 4 years association with the industry. So let us say before starting with say data science or whatsoever, let us do a down to the earth approach, and let us simply analyze those things. So what is science, right? So science is a word which is very, very familiar to us, which we have been hearing from say 6th standard, and maybe now I believe even from 3rd or 2nd standard onwards, people are used to it. So primarily what is science, right? So because of that, yeah. So in the simplest means, science is the study of natural facts, as all we know, right? We are not going to invent anything here. So what are we all trying to learn or discover is like, those natural facts, or in other words, like, science, we are trying to understand something what it like, already exists, right? So I believe, say, the definition is pretty straightforward, pretty simple, and you are all like, agreeing with me. So science is the study of natural facts, or like, okay. So to explain, say, further, planets that exist, we have not, like, the mankind doesn't, invented planet. It is in existence. But we don't know, like, why planets are like, moving the sun. We don't know, like, why the sky is blue. Or similarly, let us consider this very, simple, like, incident. Apples have been falling down, right? Apples have been falling down. So this is a natural phenomena. This is a natural fact. We have not, like, made any apples to fall, or like, mangoes, or any fruits to fall from the tree. So it is a natural fact. But one scientist thought, why is this falling? Why is this falling? So he was trying to discover what is the reason behind, those apples falling from the tree. This is science. And like, he finally, like, ended up in proposing the concluding, thing with, say, gravitational force. So he discovered that, apples are falling because of gravitational force, and he proposed, the famous thing called F is equal to ma, right? So apples falling down is a natural phenomena. That is something like, in the existence of the real world. But in science, we discovered that why is it falling down, and like, we concluded that it is because of, say, a fact called as gravitational force. Now, like, say, what is technology now, right? So we have science around us, and can we use this science to build something new, right? Can we use this science to build something new? So for example, okay, apples have been falling down, and we know, like, and we have found out that, okay, this is because of gravitational force. And now, like, we are thinking, like, the mankind was thinking, can an apple be made to go up? In other words, how to carry an object up against this gravitational force. So we come to know that there exists gravitational force, and things, will not stay, in the space because of this gravitational force. Anything, you throw up, any object you throw up will be automatically falling down because of gravitational force. And obviously, like, we were thinking how to carry an object up. And obviously, that has resulted into the discovery of, say, or the invention of, say, rocket. And, because of this rocket only, satellites have come, and satellite launching and everything. And just because of this technology, you and me are speaking, even though we are isolated, even though, like, physically we are disconnected, obviously, like, we are connected through technology. But what was the core thing, or what is the core motivation is, like, the science. So, in simple words, science is the understanding of the natural facts, and technology is, making use of the science, trying to invent something. Definitely, without technology, like, the world could have been something different. Like, about those ancient ages, how, like, the transformation have happened from the old age man to, like, the modern thing. So definitely, like, without the invention of, say, computers, the world could have been something different. Without the invention of, say, aircrafts, maybe, like, as we have seen in Avatar film or something, we could have been, like, flying using dragons or something. Or without, the invention of, say, those civil architectural things, or, say, the bridges and all, maybe, like, we could have used some olden day approaches. So obviously, like, technology is what driving. And, without technology, definitely, the world is no more. We have reached to that extent. And obviously, like, see, why data science? Why data science? So what is the core, like, reason behind, like, the world is giving so much of importance to data science, or why, like, the world is running behind this? So primarily, like, you all know, let it be Darwin's theory of evolution, okay, or let it be like, God's creation. Mankind came into this world, and then, like, we started gradually, and obviously, like, there were some transformations happening up. So initially, like, we were using, say, animals, because, like, life was pretty difficult, and then, like, we started to slave others, and then, like, the improvement happens, and obviously, like, we invented wheel. So all about it. So primarily, the first industrial revolution came into existence where, the first industrial revolution, we were trying to replace, the muscle power. Previously, like, what was the thing is like, yeah, we started off, we ourselves doing everything, and then again, what happened is like, we started inventing something new, which are purely mechanical. So what happens is like, see, we started like, use house, or we started like, taming, say, other animals for our own like, farming or transportation or other own stuff. But when somebody discovered a car, when a mechanical device called, say, a car come into this world, obviously the fastest car become absolute, right? The fastest car become absolute. So typically in the first industrial revolution, we were trying to remove the limitations of human muscle. So, maybe 10, 20 years back, like, in this first industrial revolution, everywhere, machines were coming up. And what these machines were trying to do is to, remove the limitations of the human muscle. So previously, like, it's all human. If you visit a factory, almost 90% and above of all those, like, it's all muscle power. We were like, depending on, other humans and, their muscle power. But we removed this with, like, a lot of inventions. And now, you know so we have several machines available now. But nowadays, what is the thought pattern is, we are trying to remove the limitation of the human mind. So we have everything, like, we have a tractor, we have a car, we have almost everything. It's all mechanical in nature. It will be replacing your muscle power, rather than, like, use training in the farm. This tractor is good, but obviously, like, it requires a human mind to operate behind. Yes, transportation is pretty simple, but still it requires a human mind to operate behind. So that is, where this topic is really, like, getting more attracted. And I welcome you all into, like, the world of data science, or in short, like, welcome to the world of, say, machine learning. So basically, this machine learning is like, a subset of this artificial intelligence. Or in other words, you all know about what is AI, which is again a very commonly used word nowadays. So artificial intelligence, like, it's we all know, like, how can we make, like, these machines smart? Or in other words, as I have already told, like, the main objective is to replace the human minds. So machine learning, is a subfield, but always, like, there is a lot of confusions, right? So even in my initial days, when I just, like, come into this world of, say, machine learning, I had a lot of confusions. Like, I was really finding hard to convince on those stuff. So this is the simplest definition, which I always love. Machine learning: systems that automatically learn program from data. Systems that learn automatically. So for example, artificial intelligence, we say, for example, in the simplest means, you could have all seen this film called Endiran, a beautiful film, directed by Shankar. And if you have seen, there comes, one scenario where the heroine, say, Aishwarya Rai, in the film, she's called as Sana. Sana was an MBBS student, and she wants to, like, prepare for the exams, and she will have a lot of portions to cover. So what happens is, like, say, Chitty, the robo, which is, like, AI based stuff. So she will be depending on this Chitty, and Chitty will be learning all those almost like the entire book in just seconds, and Chitty will be like helping Sana to answer the exam. So that scene. Okay, here comes the confusions. Number one, right? Where is intelligence? Where is artificial intelligence? So if you just analyze what is the core process that was happening behind, Chitty's eyes, it had a scanner, and it was just scanning all the pages. It's not a rocket science, and I don't know where is AI coming into play here. So it was all like scanning of pages, and Chitty's brain, which in the which is nothing but like say a memory, right? A memory, and these scanned pages are like say stored in that memory, and now obviously there is a storage happened. So this data have been stored in a memory, and now there is a data retrieval, there is a query request. So Sana was asking, can you tell about this? So here again what happens, the input is coming in terms of voice, and now this voice input got translated or converted into text. So this text is a plain query that, so obviously you could have used database, you could have used like say how to query, maybe at least say SQL or Oracle, whatever it is. So about it, right? So when there is something available in the table, okay, select this. So this is simply a select statement. So select this, and obviously what happens, whichever that is stored in the main memory, say Chitty's brain, is retrieved. So it's scanning a typical data retrieval. So I have really confused, where is artificial intelligence here, and how can we say claim? This lecture is mainly, if you too have such confusions, in your mind, definitely at the end of this session, you will have a very clear understanding of what artificial intelligence is and what machine learning is. Okay, and what do we mean by systems that automatically learn? Systems that automatically learn. So I don't think in this scenario, or in this particular scene of say Chitty and Sana, I don't think there is any machine learning. There is no machine learning. In the simplest means, it's just like a mere data retrieval. But let us understand, and if you have to confuse is it artificial intelligence or whatsoever, so definitely there is no machine learning. Okay, for your clarity, this is my perception. And now let us move into what is machine learning then. In other words, what does it mean, systems that automatically learn? Or is it possible? How can we make a system automatically learn, right? We are not going to do any program, but automatically we are going to make the system to. So as I have told, it's confusing, but it's all perceptions, right? It's all perceptions. It's all how you see. And if you see from the right direction, definitely there won't be any confusions at all. So primarily another one confusion or another one question that exists in several student mind is is machine learning something related with statistics? Is machine learning something related to science? So consider a scenario like this, right? We want to find the weight of a person. So what is the objective? We want to find the weight of a person. Okay, what will be the input? Height will be the input. So what is the problem statement? Given a person's height, what is the weight? So this is the problem statement. Okay, so now let us see how a data scientist will approach this problem in the ML perspective, say in the machine learning perspective, and let us see how a statistician or how a mathematician will be approaching this problem. So a statistician or a mathematician will be trying to apply whatever say mathematical modeling. So they will be knowing, and they will be giving you a mathematical model. In other words, they will be giving a equation. They will be giving an equation called say weight is equal to maybe say something called say differentiation of or integral of or whatsoever, right? So they may be coming up, say weight is equal to some constant a plus say height, whatever. So if you substitute the value of height there, you will be getting the weight, right? You will be getting the weight. So what is the input? Height. The input is the same even in the statistician's world or in the data scientist world, but the output in the statistician world is a equation, a mathematical model. Now let's see, like how machine learning guy will be approaching this thing. So what a machine learning guy will do is, okay, he will be collecting the samples. In other words, he will call his neighbors or maybe his friends. So he will call person 1 and he will note what is the height and he will note what is the weight. He will call person 2, he will note what is the height and he will note what is the weight. So he will be like doing it for say n number of people, and what he will be feeding is what he will be feeding to the machine, or what he will be feeding to the system is, he will be feeding, see, look, person A, his weight is this, his height is this. Person B, his weight is this, his height is this. Likewise, person N, his weight is this and his height is this. So now using this, automatically the system will be like finding up some correlation between this input and the output variable, and now like it will be coming up with a model. Now to this model, if you feed the input as some person, some new person, this person's height or weight is not known to the system, it will be automatically doing it. Yes, I might know, this may yeah, you some at least like could not have got that clarity, but still we will be looking in in an elaborate world. So for the time being, understand this: in a traditional programming, what we will be giving to the computer is data, program, and we will be expecting an output. So let us consider, in the traditional programming world of solving say Fibonacci series, or like say even like to add two numbers, okay, addition of two numbers, what are all those things we will be giving is, say, the two number data, say 2 and 3, and the program to solve, or the algorithm, right, or the algorithm. But in the machine learning world, what we will be saying, what we will be giving is, okay, input is 2 3, target output is 5, input is 5 5, target output. So we will be giving say data as well as say the target output, and we will be asking the machine to come up with the algorithm, right? So this is the evolution. Again, what is data science now? Okay, as we have seen, science is a field of like understanding the natural facts around us. Data science is the field of understanding the hidden facts that exist in the data. In science, we are trying to explore those hidden facts that exist in this nature or in this world naturally. So likewise, how science explore those information that exist in the nature, data science is the field that like is trying to find out what exists in the data. And as we all know, data is everywhere. Data is everywhere, right? So today almost every decision is made up of data. So if you ask, okay, is there data science in the real world? Okay, is data science something related to me? Yes, definitely yes. For example, maybe you take any company, how is the decision made, right? So previously you maybe you could have seen like their bosses coming and saying, okay, we are going to take this decision based on by experience. But now you will definitely realize most of the companies take decision based on like data. Totally gone are those days where decisions are made out of like say gut feeling. So definitely, and moreover for people who are in say academics, maybe all my friends, or even if you know any of your friends who are doing research in any discipline, they will be very much interested to analyze what they can do or to write with the data gathered, right? So even now you see the publications happening up in any discipline or totally like not like before, gone are those days. We are not finding anybody like coming up and proposing Newton's fourth law, or like say Einstein's third law or fifth law, something like that. So even now, like people are doing experiments and finding it like measures. So let it be not only computer science, even let it be chemistry, physics, electrical, definitely like or consider like academics, industry, everywhere data science is predominantly making a bigger impact. So to like explain in say some simple words, consider previously when we are going for a tour or a trip, totally we will be like calling our friends or somebody who have already visited, and we will be trying to get their recommendations. What are all those places we can see, because I am going to stay only for 2 days. What are all those good hotels or something like that? But now, how are you taking your decisions? It's all like say TripAdvisor, Make My Trip. So these like handy things are coming up in place. And how are they recommending? How are so it's so we are deciding a place where we want to go based on say data science. We are booking a hotel based on recommendations, based on feedback. Even when it comes to say Amazon, when it comes to any purchase, we take decisions whether to buy this mobile, that mobile, based on data science. We take decision even to like use this or that. Let it be like buy this computer, that computer, or whatever, it is data science. So one interesting past like scenario which I could say I could tell you is like to what extent data science has played an impact in the real world. See, I don't know, if you are 2K kids, I don't know whether, you remember those days. So in those days, when I was a kind of say school student or say even college student, let it be, maybe, in 90s, okay, in the late 90s, nobody could have heard this company called Bajaj, or in other words, two-wheeler, TVS was so popular. TVS was so popular, if you remember those things. And then what happened is like, Hero Honda came, and they really like, outperformed like anything. And they launched a bike called Splendor Plus. And if you visit a school, if you visit a college, if you visit like, the parking space, you will find the 90% of the bikes are say Splendor. So, the late 90s, TVS and Hero Honda was ruling the two-wheeler market. Definitely, like your faculty will acknowledge this. If you check with your father or like any of your elders, they will definitely say Bajaj had like maybe I think like one or two models. Maybe they doesn't even had not even like less than, I think they had only less than 5% of the market share. But they did a data science. So what experiment they did is they have categorized all those purchase segment. In other words, what they did is they have gathered data related with all those new buys. In simplest words, what they did is across India, this information is available. In a particular year, okay, how many bikes have been sold, and what are all those models? Most importantly, who are the customers? What is their age? So what was the exploratory analysis they did is, they did a simple exploratory analysis where what they did is they have categorized the age group of the new buyers. Okay, for example, let us consider in India in 2000, say 19, in 2019 to 2020. Okay, let us consider 10 million bikes have been bought. Out of that 10 million new buys, so what was the experiment they carried out is, what is the age segment? And interestingly, they found out that almost more than 70% of the new buys the age segment is, say, typically 16 to 25, less than 25 years. So this was the predominant, age segment. So then they analyzed, okay, what was the expectation? What was the expectation? So it's all modern day youth. So they want a stylish feel, and they want instant pickup. Even in certain circumstances, they want to raise their wheels. So they have clearly identified what are all those requirements. Okay, if you want to have instant pickup, if you want to instantly raise the wheels and boom boom sound and all those stuff, definitely we need to compensate certain thing. Yes, how about the mileage? Yeah, you cannot expect. But whether this group will be bothering about it, definitely no. They are not the working population. They get money from their parent pocket for putting up the petrol. So no matter, they launched a bike called Pulsar, and you all know the story behind. Now Bajaj is also a very, very popular, owning a very popular share in the two-wheeler market. So a simple data science experiment, a simple data science activity have totally, transformed a company called Bajaj from nowhere to somewhere great. And then also they analyzed, okay, next, the next popular or the dominant segment was 25 to 30, 32. So this was the case where they started earning their first money. They know the importance. They will be giving importance to savings, this and that. So mileage is the major thing, and they came up with a version called, say, Platina, Discover, and totally they captured the market. And today you are we could see more number of Pulses or Discovers on the road. So from nowhere to somewhere great, they have totally have taken a transformation. Another one interesting thing, you could have seen this. You could have seen this video, maybe definitely I believe, but it's a short video.
We're never alone. And that is our strength. Because when we're doubted, we'll play as one. When we're held back, we'll go farther and harder. If we're not taken seriously, we'll prove that wrong. And if we don't fit the sport, we'll change the sport. We know things won't always go our way.
And the world's sporting events are postponed or cancelled.
But whatever it is, we'll find a way. And when things aren't fair, we'll come together for change.
We have a responsibility
to make this world a better place.
And no matter how bad it gets, we will always come back stronger. Because nothing can stop what we can do together.
So this ad, I believe, you could have definitely seen it. One second. So definitely every one of you will say appreciate what an amazing piece of video editing. So you could definitely appreciate what a super piece of video editing. And definitely for your surprise, this is a deep learning algorithm running behind. This is not a manual editing. Don't think that some humans were human brains or human minds were behind. It is an output of a deep learning algorithm. So even in video editing, there is, data science. I believe, like, today YouTubers are, like, predominantly growing. Even, there could be several YouTubers in this aspect as well. I'm audible, right?
Yes, sir.
Yeah, okay.
Audible, sir.
Yeah, sir. Okay. Yeah. So even, like, several YouTubers could have been there, even, in this group. So even, because of the pandemic, even, like, say, uh, from at least, like, from our church perspective, we are telecasting, like, the Holy Mass in Zoom. So from then, like, I'm also a kind of YouTuber. Like, we at least, like, I manage my church account in the YouTube. So these things are, like, coming live, and we are doing it through Zoom. So even, one recent example, like, where I have used is, for example, like, we did a virtual choir, and, like, we want to so we want, like, the wordings of the songs to come at that appropriate place. For example, when a song is played, when somebody is singing a song, like, so even, like, there is a open source deep learning algorithm that exists, whereby, if you just give a video, and the text automatically, like, this will catch up, and it will automatically, like, highlight. So Google is using Facebook's friends recommendation, or, like, Facebook's several functionalities, or say Amazon, or say Netflix, or say Ghana, or even, like, in video editing, data science is there. Interestingly, okay, uh, again, like, say, even gambling, data science is there. So even, like, say, let it be a modern sport called cricket, football, or baseball. Now, say, Virat Kohli or Mahendra Singh Dhoni, or other cricketers are using, data science, or they will be having, like, their own, like, data scientists to analyze the patterns of the bowlers. Okay, so maybe, like, is there a pattern, right? Say, okay, I'm going to face this guy, okay, and he has bowled this many balls in the past, and, like, is there a pattern? Maybe, yeah, once in every fifth ball he will bowl a bouncer. Once in, so they are also, like, very much interested. Likewise, a bowler is using, a coach is using, even gamblers are using, in this match, whether India will lose or fail. In this match, how much runs will Virat Kohli score? In this match, like, how much goals, this particular country will. So data science is everywhere. Yes, so that is the first part, where I believe, like, I have made you to appreciate, or, like, I have really given you a spark to appreciate that data science is everywhere in the real world. It is very, very hard to list or find a single application without data science nowadays. So data science is almost everywhere, because data is everywhere. Data is around us. Data is around us. So yes. So the second thing is, yes, definitely, like, this area is pretty much interesting. No matter I am a computer science guy or not, no matter I am going to work in IT or not, no matter, like, I am going to become a software engineer or not, even though you are going to become a software engineer, or a IT professional, or, like, say, a researcher, or even if you are a YouTuber, data science can really give you some handy stuff. So almost, like, everywhere data science is there. Now the second part, okay, let us spend some time to understand what is data science. Okay, and let us try some time to understand, okay, what does it mean, machines automatically learning? So basically, broadly, like, these are the three things, right? So in any data analytics activity, these three parts exist, descriptive, predictive, prescriptive. What is descriptive means, understanding the past, what happened. For example, this is a real world analogy, is like, say, you go to a doctor, he will be asking for what happened in the past. What are all those, like, what are all those symptoms? So he will be saying, okay, I'm having headache, I'm having, fever, this or that. So what happened? What has happened? This is descriptive. Now predictive, why it has happened. Okay, maybe you took any food, or like so is there any change in your regular activity or whatsoever? And then like say prescriptive. Okay, so let us consider one scenario. Imagine you are a theater owner. So you have a theater, you have a movie theater. So let's all hope, we are all praying, this pandemic has to get over quickly. We are all suffering. Our life is really miserable. So yes, imagine you are a theater owner, and like things have come to normal, and you are planning to release Vijay's say master movie in your theater, right? So now you want to know, okay, uh, what could be the best price I can put it up, because like in a any distribution, like you are going to you will be like purchasing it for some like say X amount, and obviously if this movie is running really pretty good, you make some X square or X plus. Otherwise you are going to lose. So what you want to really know is, okay, what can be the maximum pricing I can bid to get this movie, and what sort of those profits. So what will be the descriptive analytics you will be doing is, what has happened in the past, what are all those Vijay movies you have played in the past in your theater, and what was the profit you have made, and what was the bid you have kept, and again like what is the, so data is there, data is there. So similarly, okay, consider this one. Yes, you have taken master first day, first show. You are totally confused. What could be the ticket you need to keep? You have two primary objectives. One, if you are keeping say 1,000 rupees, and if the tickets are like getting over in just half an hour, you are a loser, because even though it had the potential to make the ticket sold at a price of 2,000 rupees, you have really lost 1,000 rupees. So primarily you are looking for is like you don't want to lose your profit, but at the same time keeping a higher price, and you don't want any vacant seats as well. So what you will be doing, okay, you will be doing a mere descriptive analysis of like analyzing what are all those previous Vijay movies, what are all those like director or like hero director combination, music director combination that has happened, and like what was the first ticket, when at what time like the tickets got sold, what was the profit. So this is like descriptive analysis. And predictive analytics is like, okay, why the reasons, okay, any advertisements you have given, any fancy stuff you did, or so data science can really like make your world pretty like comfortable, and it will be really like helping you to take good decision. So now the modern day tools are mainly focusing on this descriptive and predictive. In other words, like what has happened, why it has happened. What is this prescriptive is, understanding that what I need to make this happen. In other words, okay, I'm going to release this master movie. I want say 3C profit. What I need to do. So this is something like the world is emerging. So yes, every company, even insurance companies are like trying to do. So tomorrow, what will be the modern insurance scenario will be like. Today, insurance is based on age. Tomorrow, definitely it will not be that case. I think like the credit score, the CIBIL score, definitely those elders will know. Previously for getting a loan, it is pretty a tough task. You need to produce a lot of documents. But nowadays, totally the scenario has changed, right? Totally the scenario has changed. It all depends on your CIBIL score. Similarly, tomorrow there will be coming something called a health score. And if your health score is low, you may be paying a higher premium for the same 5 lakh insurance or the 3 lakh insurance. But your health score is pretty high, you may be paying low. So typically, like these are all the revolutions that have been happening up. Of course, everybody wants to predict, in terms of share market, in terms of like say even everyone are interested, like if I am buying some gold, will I end in a profit or a loss? Will it really touch 70,000, 80,000 as predicted? So everybody wants to predict. Okay, so due to the time constraint, let me quickly wrap up as a kind of summary, so that like it will be so organizers, please bear another 5 minutes with me. Sorry for the delay. Okay, so consider a scenario where like you want to eat mangoes one day, and you are sending your younger brother or sister. So they are at the age of say 6 or 7, consider. So they are going and visiting a vendor, and they are seeing the scenario called, say, what is that is like, okay, there are like lot of mangoes. So your younger brother or sister is coming back to you and asking you like, see, there are so much mangoes, there are so many mangoes, and the choice is mine. I can select any mangoes as I like. So what I want from you is, what help I want to you is, whatever mangoes I select should be the sweetest. Whatever mangoes I select should be the sweetest. Can you help me in finding up a rule? And like yes, you are giving him a rule called, okay, pick the bright yellow mangoes. So this younger boy or younger girl is going to the vendor, and like he's seeing there are hundreds of mangoes, and he's selecting the bright yellow mangoes, and he is coming back. But now life is like not that simple. So he feels that not all those yellow mangoes are sweet. So now he is demanding, okay, no, I'm not convinced. Not all yellow mangoes are sweeter. There is something else to mango. So you are asking, okay, he's asking, okay, you are saying, yes, yellow mangoes, but also size. So you pick up the biggest yellow mangoes. So now like he is going to the market, he's seeing, okay, he is picking up those big mangoes. Even within that, he's selecting those bright yellow mangoes, and he is coming to. Okay, so now you are going to a vacation trip to USA, and your younger brother is using the same rule. Okay, whenever he wants to taste mangoes, his primary objective is taste the sweetest of all, and he goes to the vendor, he goes to the shop, he will be picking up those biggest as well as like the brightest mangoes. But he goes to you are in a trip, and he's applying that rule. The rule is miserably failing, and he comes to know that like here those mangoes which are like greenish red are pretty sweetest. So now like you are adding some more rule. What is it? Okay, if the location is USA, if it is not cultivated in India, this rule doesn't apply. So let us write a mango science program where you want your computer to write a mango program to help you to choose the sweetest mangoes. Okay, same like that, we will be coming up with an algorithm where our program will be following a logic. Okay, we start, we get the input as the mango color as well as the size, and we select, okay, if the mango color is yellow, and if this is size, you will be declaring based on the location, is it sweeter or not. Similarly, okay, you may be starting with the color, you may be starting with the size, and then so this could be the rule. In the traditional programming world, if you are writing a program, this is the rule. What is it? Okay, you will be getting the size, and you will be getting the color as the input, and you will be using some multiple if else conditions, and you will be concluding that whether this mango is sweeter or not. But in the data science world, what we will be doing is, you will be going to that shop, you will be going and visiting that vendor, and what you will be doing is, you will be asking his expertise. So what you will be so this is one option. Or what you will do is, you will buy 100 mangoes. You will buy 100 mangoes. You will bring all those mangoes to your house, and you will be cutting the first mango. You will label that as M1. You will look at the color, yellow. Location is India. Size is normal. Okay, shape is round, and you are tasting, it is not sweet. So is it sweet? You are saying no. Now you take the second mango, you take the third mango, it is red in color, it is cultivated in India, the size is normal. So what you will be doing is, you will be cutting all those 100 mangoes on your own. You will be like giving the feeds to each of the labels, say color, location, size, shape, and you will be like concluding with whether this is sweet or not, right? So the same thing it is happening up, and this we call as the train process. So what you will be doing is, you will be feeding this information. So the left hand side is the train set. What is it? Though the expert's opinion, So you will be labeling the mango and the size, all those labels, and like you will be also. So here What is the target output? Is it sweet or not? What is the y variable? Is it sweet or not? This yes or no, this is it sweet? Sweet is the y variable or the target variable. So now what happens? You feed, this information related with this 100 mangoes. Now you are asking, the machine to learn. So it will automatically learn on its own. And now, like, you are giving the information of a new mango, that we call it as the test set. Now, like, your model is capable of finding out. So this is the basic idea. Okay. And so to the organizers, sorry for, can I take another 5 minutes or shall I conclude?
Okay, you can take 5 minutes.
Yeah, okay, thank you, sir. So in a, okay, so let us okay, so typically, you all know about, say, this accuracy. So what we will be doing is, okay, how we will be evaluating is, yes, so this is the model predictions, right? So imagine this scenario. In other words, what is the thing is, mango, color, location, size, shape, sweet. Okay, up to this is the train set. You have given it to it. Okay, and now, like, you have trained the model. Now you have a test set, in the sense you are real time going to the shop. You are picking up a mango and you are feeding that information. You are asking, the machine to predict. You are asking the machine to predict based on the only one rule, which we call it as the feature. Now let us consider this is a single feature model. In other words, one rule model. What is that rule? If the color is yellow, it is sweet. Okay, if the color is yellow, it is sweet. For example, M1 color yellow, yes, sweet. Yellow, yes, sweet. Yes, 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 yes. So this is the predictions based on this rule. Now we have the actual things. In other words, this is the machine prediction, and you could have actually tasted and you could have noted down that inference. Okay, is that exactly sweet or not? And if you plot that information, so the sweet, yes or no, is the machine prediction. The actual thing is the actual, inference. So you will be plotting it, and you will be taking up and finding it out, right? So so your model has, like, say, there are, say, actual, see, your model has predicted 2 as yes, but the actuals is, like, say, so with that you will be finding up the accuracy, and accuracy may not be, convincing metric for all those things. So we will be also using a metric called precision. What does it means is, in other words, okay, totally, like, say, there are 100 purchases. Okay, but our model has predicted, say, 10 out of that. Within that, what is right? So within the model predictions, what is right? This is prediction. This is precision. Similarly, there is another one metric called as, say, recall. So what is recall? What is recall is, like, say, okay, out of the total purchases, how much, I have predicted it right. So typically, like, this is what it is happening up. So, we have a decision tree, we have a random forest, but obviously, so what happens is, in a rule-based world, you are framing the rule. But in a machine learning world, you are not at all giving any rules. There is no rules at all. You are giving only those actual scenarios. Whatever you know, you are giving. Whatever you know, you are giving. You are not restricting to any rules at all. So, like, say, even in a stock, okay, so the applications are, like, wide. So everywhere, like, even a loan processing, even chess, machine learning is humming up. So okay, so even, like, say, mail, because certain tasks are difficult to program by hand. How will you program a spam filter? What will you say? If this mail contains this, that, or that, definitely, it is not possible. So we cannot achieve several things using traditional programming world alone. Similarly, say, face recognition, right? We want to recognize a person. How will you say? Will you feed all those informations related with? But in the machine learning world, what you will be doing? You are giving, possible images of that person in different postures, and the machine is, like, say, automatically learning. So Google Translator, or speech recognition, automated car, games, like, say, everywhere. But what is the basic concept? collect the data, collect the target output, and obviously, use that, use the appropriate machine learning model and use it like that. Okay, so there are like say several like say algorithms. Okay, say supervised, as you all know, we have a target label. If we have a target label, this is supervised. But for example, consider like BSNL wants to construct a tower in Thoothukudi, and they want to select the ideal spot. They will be simply using an unsupervised approach, a clustering approach. What they will be doing, they will be using a clustering approach where they will be feeding all those subscriber informations. And if in particular place in Thoothukudi has the most number of say subscribers, obviously that is the ideal place to erect a spot. So okay, in the real world, okay, so one last thing. So in the real world, we are using like say the cloud heavily. So for example, today you have everything in the cloud. For example, you don't want to depend on so let me launch Amazon ML application. So I have, so today if you have a credit card or authentication just 2 rupees, that's it. So you will be able to create your own space. So yes, I think yesterday you could have got a fair knowledge about say cloud computing or say big data and all those stuff. So even all you need is a good internet connection and browser, that's it. So use AWS or use typical say cloud computing platforms like this. For example, what I have selected is a banking database. So yeah, if I want to change anything, I'll be able to give it up. So so I'm viewing the schema, and now I want to select, okay, what is the y variable or what is the target output. So all you want to do is what do you want to predict, what do you want to predict. So the target variable, so yeah, I'm doing a blind selection here. So and obviously say it will be giving you a preview. And so see SageMaker Studio. So in SageMaker Studio and all, you have autopilot models. In other words, you can in no means see there are several deep learning architectures that are available. So you don't want to do anything. You don't want to reinvent anything on your own. So there is a automated speech recognition. There is a automated face recognition. You have a AWS application called Recognition. You have AWS thing called so for speech, for face, for image classification, for say voice, for NLP, you have exclusive engine, and you have even a recommendation engine. It is a primitive engine which is a matrix factorization. So you have today several things that is available. So what is the point I would like to conclude at the last is, even doing a data science experiment is pretty simple, pretty easy. All you need is just a good internet connection and a browser, that's it. You don't want to have even any computing resource on your own. AWS or any cloud computing frameworks is that pretty simple. So with this, let me conclude thanking the organizer and my guide, Dr. Joseph Raj, for this wonderful opportunity. I believe this session could have given you some trigger and could have really motivated you as well to do some activity or to try out something very next. So with those things, I believe once again thanking the opportunity, and wishing all you a wonderful scopeful thing, and requesting all of you to try up lot more experiments and do several more research and be a vital part of this. Really, it will be good even if you start a data science club or something like that, because this is something booming. This is really something booming, where this field is definitely going to fetch you some good or best jobs in the near future. So this is really a wonderful webinar for you. Consider this as a start, and definitely there is a lot of scope in terms of everything. for everything. Let it be a job, let it be a career perspective, let it be even like, editing or whatsoever. Data science can really, help you to do things in handy. So thank you so much once again, and I wish you all best of luck.
Thank you, sir. Thank you a lot. Thanks a lot. It's very wonderful. We have a wonderful session. It is extraordinary, and you explained everything with small, lot of examples and in a simple way. I hope in future everybody will use this data science for handling the practical problems in their life or in research also. Thanks a lot, sir. Thank you. Now it's a query session. Participants can unmute themselves and ask if they're having any doubts or any clarification. So it's your time. You can ask. And you can raise your hand or you can enter the question in chat box. So I'm having one question. Suppose in company, what is the machine learning technique they are using maximum for classification? There is which classification, which algorithm, which technique can give best classification accuracy and all?
Ma'am, there is, no predefined technique, anything as such. It all depends on the data. It all depends on the domain fundamentally, and it all depends on the data. Because it all depends on the scenario. So for example, industrial requirements will be something strange. So maybe currently I am working in a say recommendation project. So what was the business objective we have received was, so this is the business objective. We want to list the potential advisors who are going to buy our product, and we need to find out the propensity of, like, say, maybe a strange terminology to you. So this is the business problem. We want to find the list of users who, and along with the probability of buying. In other words, consider, so we are a finance-based company. So what is the core thing is, like, we have a product where so we have, like, say, we are trying to bridge, like, say, the so-called, say, financial advisors as well as, say, the money managers. So in the simplest means, financial advisors are those guys who recommends, who decides on your part. For example, say in India, our major investment is in fixed deposit or, say, gold or something like that. So because I think here we have at least 5+%, but I think in US and all, you will have an annual interest of, say, 1%. So obviously their ideal sort of investment vehicle is, like, investing in, say, mutual funds or stocks or something like that. So financial advisors are the guys who will be, like, advising you to where to invest and something like that, and they will be, like, doing on their own investment. So in that aspect, like, similarly, these money managers are those guys who will be coming up with this product in the sense, like, it can be a mutual fund, it can be say, again, in the financial terminology, like, say, SMAs, FSPs or something like that. Consider, like, say, products. So okay, so this is the thing, so we are going to serve a money manager where he has a lot of products. Maybe, in the simplest means, as students are there, what I can say is, consider, we have a supermarket and there are a lot of products. We want to find out who are all those customers who will be buying this product, right? So yeah, so what I'm saying is, like, I have modeled this as a recommendation based problem, but this recommendation is not something that was something existing, that is attached with the business problem. But I have technically modeled this problem as a recommendation based problem. So likewise, okay, so for example, again, you consider, say,
அண்ணன்ட்ட கூட இல்ல நோயில் இருக்கானா
okay,
நிகில்
you
இருக்கானா
consider recommendation.
அப்ப அவன ஒரு
We are using a user-based collaborative filtering approach. We are using a user-based collaborative filtering. Within this user-based collaborative filtering approach itself, we need to invest some time where to find, okay, what can be the potential similarity metric? Is it a straightforward jugged? Is it cosine? So even like, now we have a FAISS in the sense AI similarity search. Facebook AI similarity search. So this is fundamentally one part. A lot of scope, identifying the similarity metrics. Then again, what is the
Thank you, sir. Any questions from participants?
I have one question, madam. This is Christopher. In this pandemic situation, the COVID-19 is the influencer. All other influencer or variable or parameter suppressed. In this situation, how the machine learning will happen and will work?
Sir, your mic is muted.
Sir, unmute, sir. Raja, sir.
Oh, sorry. Yeah. Okay. So, like say, in machine learning, you are trying to make a machine. In the other words, you are transferring a human expert's thing only to a machine. Correct. For example, consider the mango case we have considered. What are we trying to transform? We are trying to transform the intelligence, the expertise or knowledge of that mango vendor in terms of a model. Correct. So whatever the knowledge the model has gained is mainly based on their target output. But who has selected the target output? It is a human. So to answer your question, we have not faced such a situation in the past. So typically we don't have a target variable as such, right? So in that way, in that end, it is definitely not possible, for a machine learning to solve this. But it is possible for a reinforcement-based learning to solve. What is it? This reinforcement-based learning is learning by reward. In other words, can I beat the expert? Machine learning is like, acting like the expert. Acting like the expert. Reinforcement learning is, can I beat the expert? In other words, I want to, so yes, I have the coach knowledge, I have the expert knowledge, and I have a model. The model will also perform like the expert. Reinforcement learning is learning by reward. In other words, what are you asking the machine to do is, you try on your own, you devise some random experiments, and I will say, I will give you rewards. I will give you reward. So I think that is the idealistic way of solving, and I believe you have a wonderful session coming up tomorrow, whereby we will be just giving those samples. We won't give any expert opinion, any expertise thing there, but we will be giving reward. We will be giving, if the prediction is right, you may be giving a reward of say 1,000 points or something like that. If the prediction is say poor, you will be penalizing it with with the negative points. And now the model learns. So that is how the real world models are that is how even the real world models are beating some even beating say the former chess world champions or something like that.
Hello. Thank you very much, Raja. Thanks for Dr. Joseph Praj to produce the gem.
Pending for delivery Kamida.
Sir, is there any possibilities or special algorithms for clustering black and white images? Do we have any specific algorithms there?
I'm not a say image person. My major research or major work for the last 4 years is exclusively on the real world data, especially say the finance data. But obviously one interesting example what I can tell you is it all again depends on the situation. It all depends on the data. For example, we have used a KNN algorithm for say clustering. Okay, which is a subpart of this recommendation process. In a KNN, you are restricting the model to do the predictions based on that K value, correct? In other words, if I explain like, the model which we have built, what we'll be doing is we will be forming a neighborhood, which we call it as a cluster. So you are a purchaser, you are a user. I am trying to find out similar users. I am trying to find out similar users. Let it be there are several features that exist, but I am trying to find out similar users. If you use this KNN algorithm, you are forcing the model to come up with, say, K users for you. In other words, consider this way. You are an user and you don't have a good similarity match with almost many of the users, but still you are forcing the model to come up with 10 nearest neighbors, or 10 possible people in your cluster, but they are not your real good closest neighbors at all. Okay, so in this way this KNN doesn't work. So what we did is, we have tweaked and we have come up with our own approach, where what are we trying to do is, rather than using rather than using the number of neighbors, or rather than giving a n value as such, we are finding the similarity index, and we are finding the similarity index threshold. So consider this way: I have 20 people who are very, very similar to me. Now I will take recommendation from these 20 people, but you are one guy where you have, your neighbors are really distant apart, really far apart. So your closest neighbor is having a similarity index of, say, 0.2 or 3. Now you may not be getting anything as such. So okay, so that is the thing. In that end, again, definitely there is no hard and fast rule, or there is no definite predefined thing. And to be very precise, definitely I am not an image guy, so I have not carried out any experiments related to that. And in that end, sorry, I think I don't have a ready-made answer for you. But again, definitely, out of my knowledge, what I would like to say is, there cannot be a one single algorithm that is going to solve that. It depends on the data, it depends on those images.
Hey Raja, this is Christopher again. See, my sensibility index is 40%, but my accuracy is 90%. How I can infer the result output, and how I can recommend you can go for this machine learning?
What is your first? What is your yeah, accuracy is 90%?
My sensibility is 40%.
Okay. Yeah. So this is another one scenario which we have also come across. In other words, you cannot see like sensitivity, specificity, okay, or the so-called say the alternates say precision, recall, or you have ROC, you have again there is no hard and fast rule, or we cannot measure everything in terms of one common metric. You cannot measure everything in terms of one common metric. Again, it depends on the scenario. For example, consider our case. Okay, consider our case. We are again depending on say we are not finding out say accuracy or other. So we are using recall. Okay, so this is the thing, right? So about what is say precision. What is precision is, I am recommending say 100 products, okay, to my salesperson. I am recommending 100. My model is recommending 100 products to my salesperson. Okay, and there are totally 1,000 purchases. Model is recommending 100 products to the salesperson. There are 1,000 purchases. Okay, there are 1,000 purchases. Now, what is precision is, I'll come to your question, but I want everybody to understand what is precision and recall. So model's recommendation is 100 purchases, actual purchase is 1,000. What is precision? Out of this 100 model purchases, what is the actual buy? Actual buy is 10. So now precision is 10 by 100. Right? Precision is 10 by 100. My model has recommended 100. But actually only 10 people have bought. So 10 by 100, 10%. What is recall? Actually 1,000 people have bought. Out of that 1000, only 10 is the actual thing. So 10 by 1000. Now comes the question. You want a better recall or you want a better precision? In other words, you are the salesperson. Imagine. This is the fundamental question. See, you have two options. One, I'll give you very few high probability output, but the number of recommendations will be low. So consider this way. You are a salesperson. What are you asking is, see, I want to spend a lot of time behind the sales effort. There is a tremendous time in the sales effort. Even if you are giving 10, I need to have a 5 conversion. Now, precision is the right metric. Precision is the right metric. So, because again, the model output, there are control parameters. There are control parameters. Based on the control parameters, your recommendation will vary. Your recommendation will vary. For example, we are while recommending, we are coming up with a probability. When you tighten the probability, your number of recommendations will go down. When you loosen the probability, your recommendations will increase. Correct. So when you tighten the probability, when you increase the probability, or in other words, when you are giving the recommendation of the products which are having a higher probability, say 90% and above, the model will be capable of giving you only 10, but there will be a good precision. There will be a good precision. There will be a good precision. But imagine, you are a sales guy where you want to find out the new potential buyers of say car buying or something like that. You will be very much interested in recall. You will be very, very happy. No matter, you can take that pain. Approaching 5 people or 50 people is okay for you. But in my showroom, 100 cars have been bought. Out of that 100, say 50 is from my list. So that is your thing. So we are not using any accuracy or precision. We are using just recall. So what is the major thing? So their thing is approachability is okay. It's a matter of a mail. It is a matter of a phone call. So that pain, we can take it up. We are not going to spend any time. But conversion, the real conversion matters. So again, it depends on the scenario.
So basically, what I took it from you is that we have to, if that is the scenario, we have to test a number of scenarios, even the control charts, and then take the output to arrive at the solution.
Yes, right.
Thank you very much.
Yeah, and one fundamental difference what I have found out from the academic world and the industry is say again the data challenge. In other words, in academics, we have that luxury of simply eliminating a particular portion of the data. But in industry, the challenging component is you won't be eliminated. There will be a lot of noises in the data, and these noises will be so that is the primary thing. Again, to summarize, there is no fixed algorithm for anything. There is no fixed metric on for anything. It depends on the scenario. It depends on the data.
Okay, thank you very much, Raja. And probably I can chat with you offline. I'm more interested to discuss with you.
And Dr. Joseph Raj is a great resource person, especially neural network. He's a genius. So really you are gifted to have such a person. So definitely sir has a very sound knowledge in neural networks, and he has put that seed of that, and obviously whatever you are seeing is the fruit that has been harvested from that. So neural networks, I don't know to what extent the modern thing, this is something which I know 10 years back. So I think so he's one internal guy you are always having. So yes, definitely I strongly recommend you to make use of his expertise.
Yeah, sure. Yeah.
So before formal vote of thanks, I would like to speak few words. Dr. Raja.
Sir, I'm hearing, yes.
Very useful and nice presentation. I remember those days, Dr. Raja completed his PhD on neural network-based multimodal recognition system in 2013. he got many jobs to his option. I mean, NIT as a teaching faculty and industry. He chose a job in industry. I am very happy that the right person, Dr. Raja, had time to spare his ideas in the international webinar. I wish him all the best as he deserves for that. Thank you.
Thank you so much, sir.
Thank you, sir. Thanks a lot. I thank our HOD, head of the department, Joseph Raj, for arranging such a wonderful resource person for us. We heard a lot of informations. We got many ideas about data science from you, sir. Thank you so much. Gratitude is not only the greatest of virtues, but the parent of all others. Yes, now it's my duty to convey the vote of thanks on behalf of the Research Department of Computer Science. First, I thank the Lord Almighty for his presence throughout the program. Next, I would like to convey my heartfelt thanks to the most respected members of our managing committee, organizing committee, and technical committee who have given constant support and encouragement to conduct this webinar successfully. I think everything be perfect, and without any technical problems, the God has made us to complete this program successfully and torture the data, and it will converse to anything. Yes, now I convey my warm gratitude to our resource speaker, Dr. A.S. Raja, who taught us to torture the data to get more valuable information using many machine learning techniques. Thank you, sir, for spending your valuable time with us. Thank you. Finally, I thank all the participants from various academic institutions and industries who have joined here with more passion on learning. Thank you, one and all. Once again, I thank you, one and all. And final instructions, the feedback form have been in chat box. You can submit that. And tomorrow, let us meet again for the third day webinar at the same time, 10:45 p.m., 10:30 p.m. itself, you can join. And tomorrow we'll have a wonderful session. The brother of Dr. Raja, Dr. S. Shaja, will present from USA the topic of reinforcement learning with deep neural networks. I hope it will be very, very useful for you. Thank you, one and all. Have a nice day. Thank you.